Welcome back to 7 UIs with Replicant. Today we're having a look at the timer task, which is a real challenge of concurrency, competing user signal interactions, and responsiveness. In this task, we're building some sort of clock, I guess, where time elapses automatically. At the top, there is a progress bar showing the elapsed time against the set duration. There's also a textual representation of the elapsed time. Then there is a slider that allows you to control the duration. Dragging this should immediately recalculate the fill level of the elapsed progress bar. Finally, there is a reset button at the bottom that starts the elapsed time back into 0. Lots of interaction here. Without any further ado, let's get started. We're going to start by adding a new view to our tab bar. So we'll need to add an entry in the views here with an ID and a text, and then we dispatch on that keyword to render the timer UI. And we'll need to create that namespace as well. It will contain a very simple rendering function now that just has a header. Text large and timer. Fine. So now it should be rendering. There we go. There's a tab and here's the view. For this exercise, I figured we're going to just render the entire UI first, or at least the static parts, and then we can breathe life into it a little bit later. So at the top, there's this progress bar. We can use the progress element and the Daisy UI progress class, which has styling for it. And then we have the elapsed time as a text. Obviously, this will need to be calculated later. And then there's the duration, which is a slider, so we can use an input type range. And the Daisy range class, which is styled appropriately. And it goes from 0 to 100, and the value is the current value is 20. The 7 UI's exercise text doesn't really specify the max value for duration, so I just chose 100 on a whim. Then we'll get this a little bit more narrow and space out the elements vertically. Since we're going to put these, the elapsed time and duration should be on like a shared column, so we'll use this label function to do that. Yeah, this is going to require the containers to be flexed. Something like this. It's a little bit too narrow, so let's make it 30. And then also make sure it can't shrink. There we go. So this is roughly looking like what we want. We can put this. Yeah, and the button needs the BTN class. So this is roughly the UI that we're looking for. Next up, I want to focus on getting rid of the hard-coded values. We should really be getting these values from the state. But just like with the flight booker example, I want to write a function to compute the view state so that we can write some tests for it. Because this is where all our business logic will live. And the first test we'll write, we'll make sure that there are some reasonable defaults when the state is essentially empty. So we'll call timer get view state with empty state, and then it should have the percent that we'll use for the progress bar. It will compute the text label to display. Call it elapsed, and the duration for the range slider, which can default to 20 seconds or something like that. Now, this doesn't work. We need to evaluate the function, and it can actually just return this hard-coded value. All right. Next test should focus on finding the duration in the state. That will only change the duration here. Set it to 15 seconds. That will reintroduce our OR from before. Duration state. And there we go. Now for the elapsed, we're going to do some maths because you don't want to count elapsed by hand. You want to calculate it from the clock. So we'll set the start time when the clock starts and compare it to whatever the clock is now when we render. This is the only way to make this accurate in any way, because counting elapsed seconds in JavaScript timers will not be very accurate. So we'll set the now to be 9 o'clock, and then we'll set the actually set the starting time to be 9 o'clock, and then set now 5 seconds later. And that should give me 50% on the progress bar, 5 seconds elapsed, and 10 seconds of duration. So then we're going to have to do some time math. We'll do that in a function, get time. Now, and then we probably need to make sure that we actually have a starting time. So let's add it. If around here, I guess, we'll only make this calculation when we have a starting time, because if the clock hasn't started, you won't have a starting time. And in that case, we'll just use 0. So elapsed, and then stir elapsed here. So get time can just use literally get time. That will work both in JVM Clojure and ClojureScript, but it returns milliseconds. So we're going to have to convert it to seconds somehow. Not here, but in here, I guess. 1000. And then we need a duration in the let as well, because we need to calculate the percent with it. Like so. And what? Oh, okay. We have a ratio here. We need to make sure it's an int between 0 and 100. There we go. Test is passing. Next up, I want to make sure that we count elapsed in tenths of a second, so the UI really is responsive like the exercise called for. And to do that, we'll just add some flutter on the insts here and take a look at what we get. 46. Okay, so that's 46% and 4.6 seconds. Now to implement this, we'll just do the multiply and divide trick again, this time by 10. So multiply by 10, make it an int, divide by, oh, there we go, divide by 10. And then still false. So why? Ah, another ratio. So we're going to have to make this one not an int actually, but a float. So now it almost works, but we got 0.0. So let's just extract this as a function and make sure that if it is already an int, we don't need to display the decimal points. So I don't know what to call this. I'll just call it seconds 10. And then if there are no decimals, we'll just return the number as is. This should work, and it does. So that's cool. Next test, we will make sure that we don't calculate percentages above 100. And also the elapsed time should stop when it reaches duration. So we should have 100% in 10 seconds, and not as it is now where we get 646%. So we'll do this with min. Actually, I think not here, but we'll just go with the min elapsed, and we can use the duration as the minimum value, but we need to move duration above elapsed like so. And this should take care of all the calculations, and tests are passing. Cool. That's everything for the view state for now. Let's call on it from our render function and use the real values. Get view state, and then we set the percent on the progress bar. We put the label here, and then here is our duration. This looks the same, but is now more technically correct. We need to do something to make the UI update. And actually, we can already implement the reset button, because it's just going to put the starting time in the state. And we can do that with the search in, started, and then we're going to need to calculate the time when you click. So we'll use an interpolation for that, like we did before. clock now. We'll just create an JavaScript inst when you click the button. We can also add something to this slider, because it's just going to set the duration using the event target value as a number placeholder that we made before. There we go. Now, the starting time is set. We can drag the slider and the UI is updating. Actually, let's add another button that can allow us to just tick the clock by hand. And this can just assert or put literally anything into state, because we just want to trigger a render. And we're not using this value. We're just using it to effectively call the render function. So now you can see the time is updating. I can drag and I can click. It's approaching what we want. Oh, what's this? It says 14,031 seconds. We should have fixed that. We can capture that in this test. Just make it 14,031 and then make this one just 0, and that should reproduce the error. Yeah, we'll just make it. Another got another ratio. So this should be 70%, and it should say 14 seconds, because we don't care about the tenths, the hundredths of a second. So we're still gonna have to make this calculation here, but turn it into an int instead. We use this, and there we go. Reset and tick the clock, and it updates, and it only ever shows tenths of seconds. Perfect. Almost there. Now all we need is a ticking clock. So let's replace this manual assoc with a tick action, so we can have a ticking clock. We'll need a custom action function in this namespace for this. And what I want for it to do is to assoc the last tick, but I want to do it 1 second after you click the button. That requires some work in our machinery, so we need the now when we perform actions. We need to call this new action handling function, and we need to implement the new effect. So how can we implement this scheduling effect? Obviously, we could use set timeout, but we need to trigger actions again, and that is trapped in here. So let's make a function. We'll call it handle actions. Pass in the store and the DOM event and the event data. By having it as a separate function, we can call it recursively. And to do that, we'll just partially apply it to the store and DOM event, so you can trigger new actions with the same context. We'll set it up to process effect. And like that, now we can do set timeout, and we can call handle actions with the new actions after the specified amount of milliseconds. So now our tick action should cause the UI to update 1 second after you click it. Boom. Okay. This isn't useful, but what is useful is to trigger the tick action in the tick action, because then you will have an actual ticking clock that updates every second. And if we change this to 100, we'll update every 100 milliseconds. So this is a live ticking clock. So the only thing missing at this point really is to make the clock start ticking as soon as you enter this UI. You shouldn't have to click the tick button to make that happen. So let's get on that. We're going to take this action here, and we're going to have to make it so that a view can have some load actions, some actions to be automatically triggered when you enter the view. So we'll just make a handy little map here from the ID of the view to the view so we can easily get the actions like so. And down here, when the store updates, we'll have the old state and the new state. So then we can check if the current view is changing, then we know that we're loading a new view. And when that happens, we can trigger these actions. So we have a function to get the current view that we're already using to render. And we can call this with both the old state and the new state and compare the values. If they're not the same, then we can look in that map we created to see if there are any actions to trigger on load. So new view, on load actions. And then we can just call our brand new handle actions function. And this doesn't have a DOM event because it isn't a DOM event. So you can't really have actions that use DOM events here. Like so. Okay, so this is close, but so we can remove this ticking button. But we also need to make sure that the clock has started. It's not enough to just tick it. You also have to have a starting time. And then actually, I think we want to take these actions and move them into the timer namespace. Like so. Onload and remove the timer prefix. And now, when I go in here, the clock just starts ticking, you know? And when I drag the duration, changes how the elapsed progress is filled. If I reset, it starts over. And there you have it. That was the timer task. It's been an interesting challenge of concurrency, competing user signal interactions, and responsiveness. Once again, solved with immutable data, pure functions, and no fluff. And that's it for now. I hope you found it useful and that you'll join me for the next one. So long.